Hi everyone, so this is to help with the ship problem, and let's go ahead and read the problem and we'll highlight along as we go along. So some information at noon, so we're saying 12 p.m. Ship A is sailing 30 nauticals due west of ship B. So what would that look like? Well, I have two ships, we'll say two ships here. And A is due west, right? That's west of another ship, in this case, ship B. Okay, and we are exactly right now 30 nautical miles. And nautical miles, we'll see here, is 1 nautical mile. Oh, sorry, nautical mile is a distance for us. Okay, so it's miles on the sea. Okay, all right, we'll just write MI. A ship A is sailing west at 20 knots. Now, what is a knot? The note here, 1 knot, is a speed in 1 nautical miles per hour. So you can think of it, that's 1 mile per hour but in the water. Okay, so 20 knots is 20 miles per hour. 20 nautical miles per hour. So now A here is going to be moving in this direction at 20 knots per hour. I'm just write that as miles per hour, make my brain work a little easier. And also, how would we describe this? I would say this is in an x direction, right? And it's a rate, so I'm going to call this as dx over dt. Okay, so we can say we're moving in some x direction. Ship B, though, is sailing north, so they're going up this way, north. So now ship B is no longer at the bottom here, but after some given time, ship B is actually going to be up here, sailing north, and they're sailing at a rate of 17 knots, which for us is 17 miles per hour. Okay. So how fast is in knots is the distance between the ships changing? So if you notice, so real quick, A is someplace over here now. And how fast is this distance between them changing? And since they want rate, let's label this a couple things. Over here on our y-axis, we're going to say dy over dt. And we'll call this, let's call it c, right? Call it c. So this distance is c, and it's changing at a rate of dc over dt. And that is what we're looking for. We're looking for the rate at which this here is stretching. How far are these two ships getting away from each other? At 4 p.m. So 4 hours later. Well, if it is 4 hours later, we were both stuck right here at 30 miles apart. And 4 hours later, how far are they away? Well, our ship A here was traveling at 20 miles per hour. So in 4 hours, it added another 80 miles in distance for a total of 110 miles. Our ship B here went north, right? Wasn't it floating up? And after 4 hours, let's take 4 times 17. That was 68 miles. So it has traveled a total Y distance of 68 miles. So X traveled an additional 80, but now it's a total of 110 meters away. That's going to be our X value. Our Y value is given as 68 miles going straight up. Now, how far is that C changing? Okay. So let's see if we'll even need to find C. We'll see this in a little bit if we will. But if you can notice, this is a right triangle. And to relate all our sides, to look for the change in our hypotenuse here, we have a Pythagorean theorem. X squared plus y squared is equal to c squared. And since we're looking for the change in c, we're going to have to take what? The derivative. So we'll take the derivative of this here. Now, before I do that, let's double check. Are there any constants here? Is anyone staying constant? Is the x constant? Is the x constant? No, the ship is moving. Is the y constant? No, the ship is moving. And is the c constant? No, the c is also changing. So we can't have any easy outs here. We can't just plug any constants. So we're just going to take it as it is. Let's take the derivative of x squared plus y squared equals to c squared. That's going to be 2x dx over dt. Don't forget to chain rule that. Plus 2y dy over dt is equal to 2c dc over dt. Take your time to take a look at there. I took the derivative of x squared, but don't forget to take the derivative of x. And the same thing goes for the y and the c. Now, let's see. What was asked of us? We were asked to solve for dc/dt. And we have it here. Hey, look, we found dc/dt. Now, we just have to plug in all the other variables and see if we have everything. So, do we have an x? Well, yes, we do. We do have x distance. So, it's 2 times 110 miles. Do we have a change in our x, dx dt? Yes, we do. We said that was 20 miles per hour. Do we have a value for y? Yes, we do. We said that was going to be 68 miles, right? 68 miles going north. Do we have a change in y? Well, we do. That's 17 equals to 2. Now, we haven't solved for c yet. But how could we have solved for c? We could have done Pythagorean theorem right when we thought we needed, right at the beginning of the problem. So it's going to be 110 squared plus 68 squared is equal to c squared. And our c value is, without using calculator, it'd be 110 squared plus 68 squared. Okay. To do that in calculator now, it's going to be 110 squared plus 68 squared. Let's take the square root of that. I'm getting approximate value of 129.321. Okay, so that's actually our c value, 129.321. If you want to make this a little more accurate, you can leave it as that square root of 110 squared plus 68 squared. I think that would be a little bit safer, especially this is using my open math. And we want to fill in our dc over dt. Okay, solving for dc/dt, dc over dt is equal to, you can multiply that out together, or it's 11020 plus 268, 17. And again, you can leave that as a square root. 2 square root of 110 squared plus 68 squared. Or put it on your calculator. So let's go and plug that in a calculator. If we have a fraction, it's going to be 2 times 110 times 20 plus 2 times 68 times 17. On the bottom, it's going to be 2 square root of 110 squared plus 68 squared. I'm getting the value, the speed at which they are departing from each other is 25.9500867. And this will be in knots. Okay, so the problem, we draw it out, then we figure out what type of shape it is. Turns out the relationship is a Pythagorean theorem. Then we take the derivative looking for dc/dt from it, looking for the change in the hypotenuse.